Hello student, today I am going to discuss dispersion forces or London forces. Last class I have introduced the term intermolecular forces. Now I am continuing. Dispersion forces or London forces. Atoms and non-polar molecules are electrically symmetrical and have no dipole moment because their electronic charge cloud is symmetrically distributed. That's why no charge, non-polar. But a dipole may develop momentarily even in such atoms and molecules also. Means a dipole may develop momentarily even in atom and molecules which are symmetrically. This can be understood as follows. Suppose we have two atoms A and B in the close vicinity of each other. If or you can tell it may just what I was telling you, that by illustration, by example, you can understand it. Suppose there are two atoms A and B in the close vicinity of each other. Then it may so happen that momentarily electronic charge distributes in one of the atoms, say A. Suppose A becomes unsymmetrical, that is, the charge cloud is more on one side than the other. This results in the development of instantaneous dipole on the top A for a very short time. This instantaneous or transient dipole distort the electron's density of the other atom B, which is close to it, and as a consequence a dipole is induced in the atom B. The temporary dipoles of atom A and B attract each other. Similarly, temporary dipoles are induced in molecules also. This force of attraction was first proposed by the German physicist Fritz London, and for this reason force of attraction between two temporary dipoles is known as London force. Another name for this force is dispersion force. It is also called dispersion force. These forces are always attractive and interaction energy is inversely proportional to the sixth power of the distance between two internuclear properties, that is 1 upon r6, small r means distance between the two, 1 upon r6, where r is the distance between two particles. These forces are important only at short distance. This is important, very important. These forces are important only at short distance, means around 500 picometer, and their magnitude depends on the polarizability of the particles. Now I am going to discuss dipole-dipole forces. Dipole-dipole forces. What is this? Then dipole-dipole forces act between the molecules possessing permanent dipole. This is important things. Dipole-dipole forces act between the molecules possessing permanent dipole. In the first case, what I have discussed, London forces, that when two atoms comes close to each other, non-polar also, non-polar, when two molecules are there, A and B, then they are coming close, then there for a moment charge develops. But here I am telling you, this happens in dipole forces. Here that permanent dipole is required. Only then it is possible. Dipole forces act between the molecules possessing permanent dipole. Ends of the dipoles possesses partial charge, and those charges you can understand by taking the examples. As for example, you have seen that in any atom, sodium, suppose as positive charge, Na plus, chloride, Cl minus, like that way, these are the charge. Then here in a molecules, two end may be there, then one may be positive charge, other end may be negative. That is called partial charge also may be there. And this is actually these charges are shown by letter delta. Okay. Partial charges are always less than the unit electronic charge. Again, this is important. Whatever partial charge I told you, delta, and the partial charges are always less than unit electronic charge. The polar molecules interact with neighboring molecules. Here, understand, the polar molecules interact with neighboring molecules. Shows actually that if they will attract neighboring, they can attract neighboring molecules also. Then this will form a weak force. Okay. Then diagram I will send you. In that diagram also you can see all the things. Then the polar molecules interact with neighboring molecules. Okay, in diagram also you can see. In diagram you will see that electron cloud distribution in the dipole of hydrogen chloride, HCl. NaCl I told you, HCl also. Okay. And in this you will see dipole interaction between the two HCl molecules. In two HCl molecules you can see the dipole interaction. This interaction is stronger than London forces. Okay, London forces are weak forces, very weak. Then, but here in dipole, this is a stronger. Question is asked. This interaction is stronger than the London forces, but is weaker than ion-ion interaction. Again question is asked there. London forces is weaker than dipole-dipole interaction, but dipole-dipole interaction is weaker than ion-ion interaction. This question is asked because only partial charges are involved. That's why but ionic more charges there. That's why it is stronger. And dipole-dipole interaction is weaker. Now, just I am continuing. The attractive force decreases with the increase of distance between the dipoles. The attractive force decreases with the increase of distance between the dipoles. As in the above case, here also the interaction energy is inversely proportional. Here I am talking about the dipole-dipole forces. In this case, the interaction energy is inversely proportional to the distance between polar molecules. Inversely proportional between polar molecules. Dipole-dipole interaction energy between the stationary polar molecules is proportional to 1 upon RQ, R3, 1 upon RQ, you can tell R power 3, and that between rotating polar molecules it is proportional to 1 upon R6, where R is the distance between polar molecules. Here both you can say these things I told you. 1 upon R3, 1 upon RQ you can tell. That is, this is the, these things, polar, I talked about the energy between stationary polar molecules is, particularly in solid, it is proportional to 1 divided by RQ, R power 3, and that between rotating polar molecules, rotating, if a molecule is rotating, in that time it is 1 divided by R power 6. It is proportional to 1 upon R to the power 6, where R is the distance between polar molecules. Question is asked. Besides dipole-dipole interaction, polar molecules can interact by London forces also. This is again important. Where dipole-dipole interaction is acting, there also London forces acts. This commutative effect is that the total of intermolecular forces in polar molecules increases. Then two things now you have understood, that even in non-polar also charges develops for short time, for instantaneous, okay, for short time. And second things you have understood, dipole-dipole forces, okay. First things we understood, that is the London forces, also called dispersion forces. And second things now I discussed, dipole-dipole forces. Now third things I am going to tell, that is the third force of intermolecular forces. I told that 3 types are there. Then first type, London forces, also called dispersion forces. Second type, dipole-dipole forces. And third type I am going to tell now, that is a induced dipole forces. This type of attractive forces operate between the polar molecules. This also acts between the polar molecules, but here condition you see, having permanent dipole There also in dipole also permanent dipole was there. Here also permanent dipoles. And other things you keep. And the molecules lacking permanent dipole. It means two molecules are there, then one is permanent, other is lacking permanent, no permanent dipole. Then there dipole, induced dipole forces develops. Okay. This type of attractive forces operate between the polar molecules having permanent dipole and the molecules lacking permanent dipole. Permanent dipole of the polar molecules induces dipole on the electrically neutral molecules by deforming its electronic cloud. Where permanent dipole was not there, when polar molecules will come, which has permanent dipole, they will distort the electrically neutral molecules and charge will be developed. Okay, by deforming its electronic cloud, they create the charge. Thus, an induced dipole is developed in the other molecules. This is the important things. In this case also, interaction energy is proportional to 1 divided by r power 6. Same things like moving molecules. I told you, rotating polar molecules, same thing was there, 1 upon r power 6. Here also interaction energy is proportional to 1 divided by r power 6, inversely proportional to 1 power 6, 1 divided by r6, where r is the distance between two molecules. Induced dipole moment depends upon the dipole moment present in the permanent dipole. How much it will create charge, how much charge it will create, dipole moment it will create to the molecules lacking permanent, then that depends upon the dipole moment present in the permanent dipole. In that it will depends. And second thing, it depends upon the polarizability. It actually how much charge it will create, that depends upon two factors. First, permanent dipole, how was it was having, who is creating, how much permanent dipole it was having. And second things, its polarizability of the electrically neutral molecule. Into two factors are there. Polarizability of the electrically neutral molecules. Electrically neutral molecules where no charge was there, but how much it were ability, polarizability, that what you are telling, polarizability. Then how much charge was there for the permanent dipole moment, on that depends. And second, polarizability of the neutral molecules. Now we have discussed, may I can say this, about the larger size molecules of larger size. We are knowing that molecules of larger size can be easily polarized. Okay. High polarizability increases the strength of attractive interaction. Okay. If size is large, then it can be polarized easily, because energy involved, it is easy to remove the electron from the large size. Then from the outside, outermost electron energy can be removed. This electron can be removed easily. That's why polarizability can be done. Okay, then high polarizability increases the strength of attractive interaction. Why? Because these large size molecules of this polarizability capability is more. Molecules of large size can be easily polarized. Reason I told you, because it is easy to can say remove the electron or displace the electron from the outermost orbit. High polarizability increases the strength of attractive interaction. Now, by this way, in this case also you can understand, in this case also cumulative effect of dispersion forces and dipole induced dipole interaction exist. Means here in dipole induced dipole forces, here also other two forces what I told you, that is the dipole forces and London forces, both exist here also. Hence finally it will be more stronger. Other two forces also exist in the dipole induced dipole forces. Okay. Now in the end, now I am discussing hydrogen bond. Already I have discussed. What is somewhat new thing only I will tell you. Just in chemical bonding, last I have discussed hydrogen bonding, but here I have to tell a little more. Okay. Intermolecular forces discussed, what we have discussed in hydrogen bond. Intermolecular forces discussed so far are all attractive, or whatever we have discussed intermolecular forces, as for example London forces, dipole forces, dipole induced dipole forces, these are the intermolecular forces. Then intermolecular forces discussed so far are all attractive. Molecules also exert repulsive forces on one another. This is the new thing. Okay. Molecules also exert repulsive forces on one another. When two molecules are brought into close contact with each other, the repulsion between the electron clouds and that between the nuclei of two molecules comes into play. Means both role will come. Already I have told what happens in the two atoms. That nucleus, both be repulsion will be between nucleus, repulsion will be between electrons. Then in the same charge repulsion will be there. Then in like that way, here we are telling about that thing only, that repulsive forces also acts in intermolecular along with the intermolecular forces, where attractive forces are working, the same time repulsive forces also works. Magnitude of the repulsion rises very rapidly as the distance separating the molecules decreases. It is obvious. When two molecules are coming closer and closer, then repulsion will be more. This is the reason that liquids and solids are hard to compress. Solid you can't compress, liquid also you can say difficult to compress, because they are very close. They are very close. Repulsive forces are working. Hence, if you try to compress it, you will feel very hard. Solid you can't compress, because they are very, very close. Repulsive forces are working strongly. That's why you will not able to compress it. Liquid also you will feel problem. You will feel difficult to compress it due to the repulsive forces acting between the molecules. These are the reason I told you that this is the reason that liquids and solids are hard to compress. In these states, molecules are already in close contact. Therefore, they resist further compression, as that would result in the increase of repulsive interaction. Okay, and I will give a little idea about the thermal energy. Okay, thermal energy, you should know what is a thermal energy. This many students are not knowing this concept. Thermal energy is the energy of a body arising from motion of its atom or molecules. You know that atoms will be in motion. In a molecules, atoms will be not static. That will be always little movement will be there. Or molecules also, in a bigger molecules also, molecules will not static only in one place. It will move. It will move. Okay. Then thermal energy is the energy of the body. Thermal energy is the energy of a body arising from motion of its atom or molecules. It is directly proportional to the temperature of the substance. Thermal energy is directly proportional to the temperature of the substance. Due to that only it creates. Okay. It is the measure of the average kinetic energy of particles of the matter. This thermal energy is the measure of average kinetic energy of the particles of the matter and is thus responsible for movement of particles. This movement of particles is called thermal motion. Correct? Very important things I have told you, that thermal energy is the energy of a body arising from motion of its atom or molecules. It is directly proportional to the temperature of the substance. It is the measure of average kinetic energy. We are always using the term kinetic energy. Then it is the measure of average kinetic energy of particles of the matter and thus responsible for movement of particles. This movement of particles is called thermal motion. Today I am stopping only here. Next class again we will meet. Thank you.